I can determine the function equation that models an exponential relationship given its graph, a description, or a set of ordered pairs. Here's what you need to know. An exponential function is a function whose highest power is whatever your input variable is. And the graph of an exponential function is a curve that has a rate of change and a y-intercept. Here's what that function looks like. We have our output equal to, we have our rate of change inside the parentheses right here. You have your y-intercept, or your initial value, in front of the parentheses. And then t is your input variable. It might not say t, it might say x or h or d or something else, but your input variable is whatever variable can change value. If you're having trouble with your exponential functions, you might want to go back to lesson 508 to review writing an exponential function given the description of that situation. And then just a reminder that the entire expression inside the parentheses right here, 1 plus or minus r, is called your growth or decay factor, and it's the common ratio of the outputs. So it tells you how you're multiplying or dividing as you move from input or from output to output. You take your outputs and divide them to find that relationship. Let's do an example together. Write the function equation that's represented by this graph. So we have 2 points that are labeled. It's clearly an exponential function because it follows this nice curve right here. I can see that I probably have an asymptote at the x-axis. That's where my graph is kind of starting to level out. It doesn't look like it's going to cross the x-axis at all. This function is also decreasing, so I know that it represents decay. That means my entire value inside the parentheses is going to be less than 1. We need to go find our y-intercept, and we also need to find our decay factor. Our y-intercept is going to be the place where the graph crosses the y-axis, and that happens to be labeled for you at the point 0, 4. The decay factor is found by taking your outputs and dividing them. So I'm going to take this output, which is 2, and divide it by the output that comes before it, which is 4. And when I do that, 2 divided by 4, I get 1/2 or 0.5 as the decay factor. I've got all the pieces that I need. Now I just need to go fill into this equation or this function up here. Remember also that your decay factor is the entire thing in parentheses. So 1 minus 1/2, because we're subtracting because it's decay. That would leave us with 1/2. So this is going to be that entire value in parentheses is going to be 1/2 or 0.5. Forgot to mention that. When we put all the pieces together, it looks like this. Our output is equal to 4 times our entire decay rate right here to the t power. Pause and try this one. The ordered pairs model an exponential function where p is the function name and t is the input variable. What is the function equation? You need to go find your y-intercept and the growth or decay factor for this set of points. The first thing we can do is start to find whatever pattern we have going on between our points. So notice that your inputs are 1, 2, 3, 4. That's good. We want them to be going up by 1. It's really easy to do our pattern that way. Our outputs are changing in a different way. We've got 10, 40, 160, 640, and it's going to keep going. We can divide our outputs to find the pattern, or you could probably just see this one. It's pretty simple to see this one. Some of them will be harder, but this one we could just take any output you want. I'm going to choose 40 and divide by the one that comes before it, which would be 10. 40 divided by 10 would be 4. Each output is 4 times the previous one. That's going to be our growth factor. Because our numbers are going up, it's growing. So I know that my growth factor is 4. I'm multiplying my outputs by 4 as I move down the line. Now, we do also need our y-intercept. That was mentioned right here. The y-intercept is the place where you have a 0 for the input value, and I don't see that point right here. I don't see a point that starts with 0, so we're going to have to go backwards. I know that I'm going to be having something that's 1/4 of 10 because that's my growth factor is 4. So I'm going to work backwards to find the point that would come before it. We kind of did these 2 steps backwards. So right here, I take this output, divide by 4 to find the output that would come before it. So the point 0, 2.5 is the y-intercept. That would be the point that comes right here where I'm pointing if I were to work backwards. 0, 2.5 would fit our pattern. Again, your common ratio is going to be, you can take any 2 outputs and divide them, and you will get 4. Your growth factor is 4. Now that you have those 2 pieces, the y-intercept and the growth factor, you can plug them into the formula. That's all we had to find were those 2 pieces, but it did take some work to get there. So I know that my function, it told you that the function name is p and t is the input variable, so we need to make sure we're using p and t because the problem told us to. It's equal to our initial value, or 2.5, times the growth factor to the t power. If you want more on this topic, be sure to check out the Learning Target spreadsheet for additional resources, videos, and practice.